Yesterday we did multiplication, so today we are doing division. So yesterday, let me remind you, if you do square root of 3 times square root of 5, what does that equal?
Square root of 15.
Square root of 15. Okay, well what if I do normal 3 times the square root of 5? So what? 3 square root of 5. Does not simplify. Okay. Same thing with division. You can divide, like, guess what the square root of 15 divided by the square root of 3 is? Square root of 5. Okay, guess what the square root of 15 divided by normal 3 is?
3.
Does not simplify. Does not simplify. So this works, this doesn't. Okay, you can multiply and divide square roots with square roots, or cubed roots with cubed roots, or normal numbers with normal numbers, but they don't really mix with multiply and divide. Okay, here's the problem though. If I had like 5 divided by square root of 3, that doesn't work. However, they don't call this simplified, because they don't like it when you leave a square root on the bottom. There is a reason for it. Maybe I'll mention it tomorrow. But they don't want you to leave the square root on the bottom. If you have a nice calculator, it can automatically fix it. Of course, if it turns into a cube root, then your calculator will start failing. But
you just like put a square root of 3 times 0.5.
okay, so no.
What did I do?
Okay. Here's the trick. You can change fractions by multiplying the top and the bottom of the fraction by the same value, right? Like 2/3 is the same thing as 4/6, for example. Okay, and we can use that trick to get rid of the square root, because if you ever multiply a square root times itself, what's the square root of 3 times the square root of 3?
9.
Square root of 9, which is 3. So that happens anytime. What's the square root of 5 times the square root of 5? Square root of 25.
Which is 5.
5. So if you square a square root, it just comes out as a normal number, right? Okay, so if you multiply the bottom by the square root of 3 to keep the fraction equal, you have to multiply the top by square root of 3. So the bottom becomes square root of 9, 3, a normal number. The top becomes, what's 5 times square root of 3? 5 square root of 3. Okay, can I do anything else? Do those reduce? No. If the 5 and 3 reduced, then you would need to reduce that. Some of these problems, the normal numbers will reduce. But these two don't reduce at any time. So that would be that. Okay, so even though this doesn't really divide, we can't leave the square root on the bottom, so we have to multiply the top and bottom by the square root. All right. Let's jump in. Does anybody know where we left off yesterday?
I'll start. No.
That's what you said yesterday, and I do not believe you.
No, I think it was something
No, because
It was James.
we went past Brooke.
It was James.
It was James.
went yesterday. No,
we went past Brooke.
I watched the
Case.
video.
It's Case.
Oh dear. What?
Oh dear.
I was hoping no one would say that.
I've never watched it. Case, you should have.
Okay.
I understand it, so I don't watch it.
Brooke is next, right?
Yeah.
Don't worry, Wyatt. We'll get to you. We'll save the best
We
for
should go
last.
to
The
back row hasn't gone in a while.
No, yeah, the back row has
The front row
hasn't gone. I don't remember the last time the back row was.
It was yesterday.
Honestly.
Yesterday you guys can you not?
Okay, it doesn't matter. Doesn't
You were
matter.
the first.
Okay, on this one, these don't divide, but square root of 4, right? Square root of 4 and square root of 25. Square root of 4 is 2. Square root of 25 is 5. Okay. A lot of you do have calculators that can handle square roots, but once we get to 17, that's when it'll get messy. Not on that one, no, not really.
We'll be on number two.
Okay, yeah, I would divide on number 2 first. Square root of 80 divided by square root of 20 is
5.
square root of 4. And what's the square root of 4? Okay, on 3 they use the division symbol instead of the division bar, but I'm going to use the division bar. Brooke, does this divide?
No.
No, but what can we do? Square root of 4 is 2. Okay, can we do anything else to that? No. Okay, only when the square root is in the denominator is it a problem. If it's on top, no. And if the top had been like square root of 20, we would have to simplify that, just like the past 2 days. If the square root simplifies, we do need to handle it. But 5 is as simple as it, square root of 5 is as simple as it gets. Okay, number 5 is kind of like number 2. Square root of 8 divided by square root of 4. So if it does divide, I would do that first. I wouldn't change the square root of 4 into a 2. You could, then you'd have to simplify square root of 8 and then it would reduce, but if it divides, I would definitely, or even if it reduces, I would definitely do that first. So, oh, and what is square root of 8 divided by square root of 4?
2 would be on the bottom
Okay, I said, if it does divide, I recommend you divide it. So what's square root of 8 divided by square root of 4?
there. 2 on the top, 1 on the bottom.
Okay, what's square root of
I'm
8
dividing.
divided by square root of 4?
2.
Square root of 2. Okay,
Holy.
and does that simplify?
Bro, some people don't get math as easy as you guys.
Okay.
Answer the question.
Alright, anyways, he was trying to do something else. So you can actually do it the other way. It would still work. He said square root of 4 is 2. This is the harder way though, so I was trying to avoid it. Square root of 8 simplifies to 4 times 2. And that's 2 square root of 2. And then the 2's cancel out. So that's the long way around, but yeah, that works too.
Number 6.
Okay. Square root of 10 over 3 square root of 5. Okay. Miranda, can we divide those two things right there, do you think? Yeah. So what is the square root of 10 divided by square root of 5? No, you're thinking subtraction. 10 divided by 5 is 2. So it's gonna, these two, you can think of them like reducing, like 10 divided by 5 is 2, but it's still a square root. So it's gonna be square root of 2. The 3, we didn't really do anything with the 3. And can we do anything to that? No. The square root of 2 does not simplify. It's done. It's done. They don't divide. Number 9. Okay, it's 3 over square root of 13. So those, Moses, do those divide? No. But we do have to do something. Do you remember what I said?
Multiply it by square root of 13.
Right. They don't like us to leave square roots on the bottom. So the way we handle it is we multiply the top and bottom by square root of 13.
So it'd be 3 square root of 13 divided by 13.
Right. Yeah. Square root of 13 times square root of 13. You could plug it in your calculator, but anytime you multiply a square root times itself, it's just going to be that number. Okay. Do these reduce? No. They never will reduce the square root of the normal number. The 3 and the 13, this number sometimes reduces, the 3 and the 13, but in this case, no, it does not reduce. Okay, 11. So, Brianna, we got a square root of 6 on the bottom. So do you know how we're gonna handle it? Okay, so Moses on the last one, we had a square root of 13 right here. And he said multiply the top and bottom by square root of 13. So what do you think we should do on this one? Yeah, by just itself. So multiply top and bottom by square root of 6. Okay, the top is 1 times the square root of 6, which is 1 square root of 6. It's just square root of 6. 1 times anything is just itself. If it had been a 2 or something, we just put a 2 right there. But if it's just a 1, we don't really need to write the 1 down. And the bottom, what's square root of 6 times square root of 6? 6. And again, these do not reduce. Like I said, a lot of your calculators can handle 1 through 16. 13, square root of 14 divided by square root of 21. Okay, these don't divide exactly, but they do. Mallory, do you know what we can do with this one? Okay, if we had a normal fraction like 14 over 21, what would we do with that? You could reduce it because these are both divisible by 7. So same thing with square roots. You can divide them both by square root of 7. So they reduce. When you divide by square root of 7, they're still square roots. So this would be, if you divide by square root of 7, 2, and this divided by square root of 7 is 3. Okay, but we still have a problem. We can't leave the square root of 3 in the denominator. So how do I get rid of it? Yeah, top and bottom times square root of 3. So this time, those actually can multiply together. Square root of 2 times square root of 3. And the bottom is square root of 3 times square root of 3. Square root of 9, which is normal 3. Square root of 5 over square root of 15. All right. Josiah, any ideas on this one? Okay, it's kind of like the last one. You can't really divide 5 by 15, but you can reduce them. What do 5 and 15 normally reduce to? If you divide them both by 5, what do they reduce to? Right. So what we're doing is dividing by square root of 5. So this will become square root of 1. Do you guys know what the square root of 1 is? 1. And what's 3 times 1? 3. So it kind of just goes away. And down here, square root of 15 divided by square root of 5 is square root of 3. Okay, the square root of 1 just kind of just goes away. And Josiah, do you know what we do at this point when we have a square root on the bottom? Okay, you multiply it by itself. So if you do that to the bottom, you have to do it to the top as well. So the top is 3 times the square root of 3, which does not simplify. And the bottom, square root of 3 times square root of 3 is square root of 9, which is 3. Okay, does this reduce? Yeah, this is the first time this actually reduces. The 3 and the 3 cancel out to 1 and 1. So it's just 1 square root of 3 over 1. It's just square root of 3. steps, weren't there? All right, now we're in the danger zone. In fact, I'm not going to ask Corbin to help on this one. Maybe the next one. Okay. So if you have the cubed root of 1/2, that's like the cubed root of 1 over the cubed root of 2. Okay, everything is just inside the cubed root. And the problem is they don't want the radical. This doesn't divide. There's nothing we can do here. But they don't want the radical symbol, the cubed root, in the denominator. So how do we get rid of it? Well, previously, we just did this. But now it's not going to work because cubed root of 2 times cubed root of 2 is cubed root of 4. Does 4 have a cubed root? No, it does not. But you know what does have a cubed root? 2 times 2 times 2, 8. So if I multiplied by the cubed root of 2 a couple times, or you could just say I'm multiplying by cubed root of 4 once, that's the same thing. That would give me the cubed root of 8 on the bottom, and 8 does have a cubed root, it's 2. Because 2 times 2 times 2 is 8. So if you're doing cubed roots, you kind of have to do the number twice. Does that make sense? So the top, you actually don't have to write it like this. You could just say times cubed root of 4 instead of like that, but that'll give you a little bit of a visual. So the top is 1 times 2 times 2, so it's the cubed root of 4, which does not simplify. And the bottom is 2 times 2 times 2, cubed root of 8, which is normal 2. Alright, this is where the calculators start to fail us. If you put it in the calculator, it'll give you a decimal, which is not what we want. So, don't even try it. Well, you can try it, just don't write it down. Whoops, 19. Okay, on 18, I'm going to help you guys a little bit. On 18, 9 does not have a cubed root. Do you guys know what 9 can go into that does have a cubed root?
81.
You're right the first time. It's 27. Because 9 is like 3 times 3, right? So if we multiply by one more 3, it'll be 27. 27 is made up of 3 3s. So on 18, what I'm saying is you want to multiply the top and bottom by cubed root of 3. And then your denominator should no longer be a cubed root when you do that. So it's cubed root of 1 over cubed root of 9 times cubed root of 3 over cubed root of 3. Okay? 19. Oops. All right. Well, before I try to fix the denominator, Corbin, do you know anything special about this one? Yeah, those reduce. Those are both divisible by 9. He said 9 times 4 is 36. So if we divide both of them by like the cubed root of 9, divide them both by 9, we get 1 and 4. And if you can divide or reduce first, that's the way you're going to want to go. Okay, but we can't leave. Do you guys know what the cubed root of 1 is? It's 1. 1 times 1 times 1 is 1. So can't leave cubed root of 4 in the denominator. 4 doesn't have a cubed root, but what can 4 change into that does have a cubed root? 8. How do I turn it into an 8? Times a 2. Okay, it's because 4 is made up of a couple 2's already. So when you multiply by the third 2, 2 times 2 times 2, that number will have a cubed root of 2. Alright, the top, 1 times cubed root of 2 is cubed root of 2. The bottom is cubed root of 8, which is normal 2, just 2. Alright, what's 20? What's 20 look like? 20 looks almost the same.
How'd you get 2 on the bottom?
Because 4 times 2 is 8, and 8 actually has a cubed root. So it can turn into a normal number. That's what we're trying to get to. Can it turn into a normal number? Mallory, put your computer away. 21. 21 is very similar. 5 and 25.
Makes me want to throw up.
All right, AJ, any guesses what we could do first here?
Reduce
Yeah, exactly. They reduce, just like the last one. 5 does not have a cubed root. 5 has a square, or 25. 25 has a square root, but that's not what we want. So, yeah, they're going to reduce, kind of like the last one. It's if you divide them both by 5, they become 1 and 5. That doesn't help as much on this one, but I still should probably do it. Okay, 5 does not have a cubed root. What does 5 go into that does have a cubed root?
25. I'm not 25.
Well, whatever 5 times 5 times 5 is, right? So if I multiply by 5 a couple more times, that's definitely going to have a cubed root.
125.
Yeah, it's 125. Now, I don't even need to know the 125 because we're just doing the cubed root of that. So yeah, it is cubed root of 125, but that's not what we're going to write. We're just going to write 5. Okay, that's what we're going for, the normal number. We found a cubed root that actually works, and it turns it into a 5. The top is 5 times 5 times 1 is just 25. Cubed root of 25. All right, kind of tough, huh?
My brain is starting.
We're trying to get rid of the radical in the denominator. 5 does not have a cubed root, but we need to change it into something that does have a cubed root. 5 times 5 times 5 does have a cubed root, because 5 cubed is 125. Like if we did the little tree here, there's 3 5s and 125, so that's why there is a cubed root of 125. It's fine. All right, 22. That one doesn't reduce. I'll just do that one with you guys. We'll just go to 22. That's probably enough. We'll forget the letters for today.
So, no 23 and 24?
Nah. Yeah, this one's a mess. Okay, there is something smaller than this that would work, but I would just do the same trick I did last time. I just multiply by cubed root of 12 twice. Okay, I don't know in my head, without thinking about it for a while, what 12 times 12 times 12 is. But whatever it is, the cubed root of that is definitely going to be 12. Okay, I don't need a calculator. I'm just going to say it's going to be 12. Okay, but if I multiply the bottom by that stuff, I have to multiply the top by it as well. Okay, the bottom is just 12. The top is kind of a big number.
120.
Yeah. Okay, but we kind of have a problem here. 720 simplifies. This one's big enough. There's going to be a triple in there, okay? So we're going to kind of take out. What could go into 720, anybody? Taking one out's like doing nothing, so you can't use one.
72.
Okay, let's do 70. If you use slightly bigger numbers, it breaks down a little bit easier. Let's do 72 and 10. Any way you do it, it should come out the same, though. It doesn't really matter. If you use 2s a lot, it just makes the tree really long. That's what happens. You want a really long tree. Okay, since this is a cubed root, we need to take out a triple. So a 2 comes out, that's the only triple, and all this stuff is left behind.
You multiply the 3.
3 times 3 is 9, 5 times 2 is 10, 10 times 9 is 90. So it's 2 comes out, cubed root of 90 is left behind. Maybe I should make a bonus one of these. Yeah, I'm not going to make a on a bonus. Okay, and then the 2 and the 12 reduce here.
You should make 24 bonus.
Maybe I will. Let me look at it.
Wait, are we not doing 23 and 24?
No. Yeah, you can do 24 is hard enough. We hadn't even done any letters today, so it'll probably be challenging enough. Yeah, if you want to try 24 for a bonus, you can do that.
Challenge.